Hello and welcome to KU Radio Science, a podcast by Khalifa University. Welcome.
Thank you very much. I'm very happy to be here with you today.
Why don't you go ahead and introduce yourself, let us know what you do here at the university.
My name is Lourdes Vega. I am a professor in the Chemical Engineering Department, the founder and director of the Research and Innovation Center on CO2 and Hydrogen, which we call it RICH in short. We are not rich in money yet, but we are rich in knowledge. We hope to be rich in money also so that we can do more work in this area. And I'm also the senior director of the Petroleum Institute in Khalifa University.
There's quite a lot going on.
Yes, but it's a hot topic also.
It is. And that's what we're talking today. We're going to talk the hydrogen part of RICH, not necessarily, well, I suppose carbon dioxide kind of comes into it a little bit, but we're mostly talking hydrogen today. And I wanted to talk about the hydrogen economy because I feel like that is such a huge topic at the moment. Everybody's talking about it. And I don't know if you saw the news as well, but a couple of days ago, there was the first hydrogen-powered train set out in Germany. This train has now replaced diesel trains, fully run on hydrogen. And my first question to you is, I thought hydrogen fuel was rocket fuel.
Yes, well, but hydrogen is putting itself as to be everywhere. But I tell you why, okay? Because hydrogen is not new. I personally have been working on hydrogen for more than 20 years. And I was working for a company before joining the university again, because I have been in both sides, that were delivering hydrogen. So this hydrogen had up and down, and it depends on what will be the market. And that's what we have to think. Where is hydrogen to be used? If it's going to be used in many places, then it's a big market. If it's going to be only in one area, it's a small market. So the movements go with that. So why we talk about hydrogen now, as you say? Well, because there is a breakthrough in the use of hydrogen in the concept of decarbonizing the economy. And I will explain that. So we are emitting a lot means a lot, of CO2 and other greenhouse gases into the atmosphere. If we don't do anything, we may destroy our planet, to tell the truth, in the sense that climate change is a fact, and it's a scientific fact demonstrated. So there are actions towards avoiding this or coping this.
Yep.
And this is, for example, the Paris Agreement. We will have here the COP28 next year. All these things are politicians, governments, people with power to forbid to do things or to cop what we do that are taking actions for this. And this is clearly needed. So how do we do this? Because this carbonization that we have is related to the quality of life that we have, the energy that we use, and all transportation, all these things we need, correct?
Yeah,
so,
I mean, we demonize fossil fuels, but actually they're what brought us into this age where we're so connected, where we have all that we have.
Exactly. So we are not going to stop that. You cannot tell anyone, hey, don't use your car anymore, go walking. This is not going to happen. The same as the air conditioning. We are not talking about this, but refrigerants also have a great impact into the environment.
The
We can talk about this another day. But the point is that, are you going to tell people to stop the air conditioning?
Not here, no.
No. So then the point here is, how do we help the environment and the future generations without stopping the quality of life, the security in the energy that we have, etc.
Yep.
So we talk, for example, about having renewable energy, which we do in the UAE. We have one of the cheapest solar energy in the world. Okay, so can we really replace all the energy we have today with fossil fuels from renewable energy? No. Why? Because we have the intermittency of the renewable energy, correct? So
the
we
sun
have
doesn't
great
shine
sun
all
here.
day long.
Exactly.
Yeah.
So the sun comes when it comes, and then sometimes we have the dust, so the sun won't arrive to where it has to arrive to produce energy. And then in other places, they rely on the wind, and the wind blows whenever it blows, etc.
Yeah.
Okay, this is the change in the breakthrough that we have with hydrogen now. So hydrogen has been always seen as a way of transportation because it has more autonomy than the electrical cars, for example. And I have been involved in several projects in Europe before coming here on transportation using hydrogen. But that market is small, going back to the point. However, if we now link hydrogen to energy storage, we are covering the gap that we have on using renewable energies. I explain myself.
Okay.
And this is, by the way, what is changing, correct? So we have we can put a lot of solar energy, let's say, to compensate the demand that we have so that we have the energy that we need. But in some cases, we can have an excess of solar energy, which you cannot use because it's not demanded. So
we produced way too much.
Exactly.
We can't store it for later. So it's just gone. Okay.
This is the point. So let's try to find a way to store hydrogen for a long term. To store solar energy or renewable energy for a long term. This is where hydrogen comes into play. Because you can use the excess of renewable. Breaking the water molecule is expensive in terms of energy. So it requires a lot of energy to break the water molecule.
That was going to be a question. Where are you getting the hydrogen? So it's coming from splitting water.
We talk about this later.
Okay.
I will talk about the colors of hydrogen later. And that you will see that hydrogen has no color, but we talk about many colors of hydrogen, which is interesting. So let me put that in the context of the renewable energy and the decarbonized society that we need. So if you use the excess of renewable energy to break the water molecule, or here in the US, we can also break the H2S molecule. So instead of oxygen, it has sulfur.
That's the byproduct from gas and oil.
Correct.
Okay.
Which we have here a lot. So if we break either water or H2S to produce oxygen and hydrogen in the case of water, or hydrogen and sulfur in the case of H2S, then we can use this hydrogen to produce power back when it's needed.
Okay, so we've got power from the sun. That's come in as our renewable energy. There's only so much demand for that energy at the time. We currently can't store it. So instead of just releasing that energy and saying, oh, well, oops, we can put that into splitting these molecules to create more hydrogen that can be used for more energy. So there's nothing lost down the chain.
Correct. Well, it would be, in an ideal world, it would be perfect if the way of converting hydrogen back to power had an efficiency of 100%. This is not the case, but still it's better, correct?
Yeah, it's better than nothing. Absolutely.
Exactly. So this is what is called today power to power. Okay? And this is what I see a big change, and that's why we all are talking about hydrogen in the context of net zero emissions, decarbonizing, etc. Now, once you have all this hydrogen that you produce, we talk about the colors later, but imagine of this hydrogen we produce, now we can open many other applications of hydrogen. So that will come to the train we were talking about. It could be also for transportation. It could be for combined heat and power to replace natural gas, so then less carbon emissions, or some other applications in addition to the traditional applications of hydrogen, because we have always used hydrogen for refineries, for producing fertilizers, and for the chemical industry. Methanol production comes from hydrogen.
I didn't know that.
So these are the three main applications of hydrogen today. And we don't have more because the market was not ready for that. So together with the applications and with improving the efficiency on producing hydrogen, we are working on what other applications we can have of hydrogen.
Oh, wow. Before we go on to the colours of that, you've mentioned that a couple of times. I just want to touch on one thing you mentioned, that was energy security, because that's also a huge topic at the moment with everything that's going on in Europe particularly. And the production of hydrogen for use as fuel, can that help with our energy security needs? Or is there a bit of an issue with producing enough hydrogen to replace that?
Excellent question. Hydrogen is not the solution.
Okay.
And this should be very clear for everyone. And I am a fan of hydrogen. Hydrogen is part of the solution. And this is the way we have to see it. And when we talk about how do we produce hydrogen, we will see why it cannot be the solution. So now in Europe, what is happening in Europe, especially right now, is that they were relying all the energy production on natural gas from one source. So you put all the eggs in one basket, which is not the best way
Turned out that wasn't the best idea.
managing what you do, correct? At that time looks good, but in general, this is not a good idea. So while in other places, like in the UAE, for example, we have different sources of energy. So then when one fails, you have another one. In general, even without talking about carbonization or decarbonization, correct? So in Europe, they have a system in which they were trying to remove producing power from carbon, which is much more or noble link with environment,
Yeah.
it produces a lot of CO2 by other sources with less carbon. And in this case, using natural gas has less emissions into the atmosphere than carbon power plants, correct? But then, of course, it was combined with other sources of energy. The point is that the other sources of energy used to be very expensive. Now, natural gas is more expensive than the other sources. Would hydrogen be the solution? I don't think so.
Okay.
At least no hydrogen from water. And we will say why. Okay? So we need to diversify the way we produce energy. And the way we produce energy will depend very much on where you are. So where are your natural sources to produce hydrogen? And then you go to the UAE, and it's amazing because this country is rich on everything. So the country is rich on methane, natural gas, oil, which is what we have been doing before, and came with the wealth of this country, of this part of the world. But the country is also rich in sun. So you can produce renewable energies. We are not rich in water, though.
Yeah.
Which is a problem.
Yeah, has been a little bit.
But if you produce hydrogen from saline water, then we have a solution.
Really?
Yes, but we still have to work on this. We are working on this in the Rich Center. So what happens now? If you produce hydrogen from water, you need to have pure water. Because if you have other things coming with the water, it will affect the electrolyzer. You need to have other materials to avoid corrosion.
That's why I was confused. Because, yeah, okay, it's still water. But it's dirty water for what you need. So what are you doing with all the
more
salts
than
and everything
dirty
else
water,
in
it has a lot of saline.
Yeah.
Correct? So you have these ions that will be difficult to handle. But there is research at the lab scale, and as I say, not only us, other people are doing this. And we have to be smart on doing better reactors or electrolyzers that can handle this directly at a large scale. Right now, what we do, for example, in the project that we have in Dubai, in Diwa, which is not the only one, but it's a very important one. We have a very cheap solar power, so we can break the water molecule, but this water is desalinated water. So why would you use the desalinated water for other use, for hydrogen instead of other uses? You really need to have an excess of water to do this. So it's tricky, It's tricky. So maybe, if you want, we can now talk about the colors of hydrogen.
What are the colors of hydrogen?
So hydrogen has no colors.
The hydrogen itself?
Hydrogen itself has no color and no odor either. Okay, and it's a very light component. It's everywhere in nature. It's the most abundant element we have on Earth. Not only on Earth, everywhere.
Everywhere. Okay.
Everywhere. But you don't find hydrogen alone. Okay, so hydrogen is always with something else. Okay, so how do we produce hydrogen if we don't find it? So the traditional way, the industrial way of producing hydrogen for the three applications that I mentioned, refinery, fertilizers, ammonia, and chemicals, is by what we call steam methane reforming, that I will explain.
Okay.
Steam, water, methane, CH4, methane, natural gas. Okay, and reforming is a process, is a chemical reactor in which we do this. So with this, essentially what you have, if you think of a box, what is entering and what is leaving. Okay. So what you have entering is methane, water, and energy. Then the reaction happens inside, and when you have leaving your reactor is hydrogen and CO2. Because we have H2O, CH4.
So we hydrogen bunch together.
You break the two of them, and then you will produce CO2, carbon coming from the methane, oxygen coming from the water, and all the hydrogen coming from these two guys.
And how much energy does that take?
So this energy take on average 7.4 megawatts per hour. Okay? So now if you do the same, but instead of doing this with methane, you do this with water. So now entering in your box, you will have only water, no methane, and energy. And in the acid, you will have hydrogen and oxygen, no CO2. For producing the same amount of hydrogen, let's say 1 ton of hydrogen, which is the number I gave you before, you need 9 tons of water, I think, and then you need 34.5 megawatts per hour.
That's a lot more.
Exactly. So that's why when we talk about producing hydrogen from water, we need renewable energy.
Yeah.
Because otherwise we will use much more energy to produce hydrogen than the one we use today to produce it with methane.
At which point there's no point.
There is point if you have an excess of renewable energy.
But that's what I mean. If you don't have the renewable energy and you're relying on fossil fuels to do it.
So let me put names to the two colors of this hydrogen. So the hydrogen we produce from steam methane reforming, sending the CO2 to the atmosphere and using the hydrogen, that's what we call gray hydrogen.
Gray, okay.
Now, the hydrogen we produce using the water and the energy to produce hydrogen and oxygen is what we call, with renewable energy, is what we call green hydrogen. Now, remember my first process, the one that is used today in industry. If I put a unit to capture the CO2 so that it doesn't go into the atmosphere, then this is called blue hydrogen.
Okay.
This will require more energy because I have to add one unit to capture the CO2, but it will be a low carbon hydrogen. So you see in the media here, you hear a lot about the UAE is going to export, because we produce much more than what we need for the country, blue and green hydrogen. You see now where it comes from.
Yeah.
So for the customers that want to have low carbon hydrogen, we can sell blue hydrogen and green hydrogen. And you see now also in the RIC Center, we work on CO2 and hydrogen.
Yes.
So it all matches, correct? But now there are other colors of hydrogen you can produce. For example, if you use nuclear energy instead of the energy from the grid, which we also have nuclear energy here, this hydrogen has two names. I don't know why. So one is purple and the other one is even three names, red or yellow.
Oh, okay.
So I don't know why they still didn't agree on the name of that hydrogen. Purple is the most standard name,
Okay.
but it could be also yellow in some cases. You can also get hydrogen from biomass, like from the biogas, or from dark fermentation, so you have the microorganisms to produce hydrogen. So this hydrogen is usually white hydrogen or biohydrogen.
There is so much going on here.
Yeah, wait, it didn't finish. We also have turquoise hydrogen. The turquoise hydrogen is what you get. Remember, methane has CH4,
Yes.
so 4 atoms of hydrogen. So if you get a pyrolysis process, burning the methane, you can get carbon, black carbon, and hydrogen. That's the turquoise hydrogen. Of course, this is energy intensive, but it doesn't produce CO2. So there are all these colors of hydrogen, that the name of the colors of hydrogen come not because hydrogen has any color when it leaves the process, but because of the way it is produced. Some of them are low carbon to zero carbon emissions. Some of them will have more CO2 emissions.
I'm assuming then the challenge comes from which way of producing it is best for which use case.
Exactly. So it goes with what are my natural resources first, because I need to produce it from whatever I have. So for example, Spain has a big, very ambitious plan on using hydrogen and delivering hydrogen everywhere. They do have a lot of sun as well, and also water, much more than us. And they have no methane. So there is no way they can produce blue hydrogen, but they can produce green hydrogen. They need to have the excess of energy that we mentioned before to make it economically viable. So then, for example, Japan, no ways to produce hydrogen. So they will import the hydrogen from the UAE, from Saudi Arabia, etc. They are asking, and this is the whole thing here, Japan is asking for low carbon hydrogen.
Okay.
So we cannot sell gray hydrogen.
Yeah.
We have to sell blue or green hydrogen. I want to give you another number, and then we may talk about science if you want. But this number is very important. So of the hydrogen that is produced today, mainly used for refineries, fertilizers, ammonia, and chemicals, 76% is produced gray.
Oh.
Only 2% is green.
Oh.
And the other is produced coal, that I didn't mention this one, black or brown, by gasifying coal. Okay, mainly in China. So yeah, this is what we have. Why I'm telling you? Because my students the other day were so enthusiastic, talking about green hydrogen like this is a reality. No, This is not a reality large scale yet. Yes, we are working on it, but we still need research and development and investment on doing this, because we need to improve the efficiency of the electrolysis, where you produce the hydrogen from water. For example, you can use other sources that will be better. For example, in REACH, we are working on photocatalytic, which means using directly the sun. Instead of using the sun to produce energy, use the sun directly to break the molecule. But you need to have better catalyst for this, etc. Once you produce the hydrogen, there is another question. This is part of the answer to your question. What do we do with the hydrogen? So imagine here we can produce a lot of hydrogen. But now we need to store it if we are going to use it, or we need to transport it
To where it will be
to
used.
where it's going to go. And when it goes there, it has to be stored there, or it has to be used for the different applications. Here are more challenges associated with
Is
that.
hydrogen the one that blows up?
Hydrogen is flammable, highly flammable.
Okay.
But this is good and bad. Because I have a photo, we are in the radio, but I have a photo I can show you later in which you see what happens if you have an ignition, a fire, in a hydrogen car and in a gasoline car. And the gasoline car is much more dangerous.
Okay.
Because it's heavier, then it will flare from the bottom, so it will explode. The hydrogen car, it will go to the top because it's very light. Okay, so yes, in order to use hydrogen, the same as to use natural gas or gasoline, we have to take into account safety.
Yes.
And this safety will come with the properties of this gas. And that goes back again to the transportation. This gas is very light, the density is very small. So in order to transport this, we need to compress.
Yep.
When we talk about compression, we talk about, again, energy. No? Because you have to push something to increase the pressure. So that requires energy, which means cost.
Yeah.
And then because of the low density that it has, you have to compress a lot. So to have liquid hydrogen, then you will need a lot of compression. Not only that, the temperature is very low to have it liquid, so you need to have cryogenic tanks or something very well insulated. So how do we transport the hydrogen? One option is what I say, compressed or liquid. The other one is putting the hydrogen in some molecules. For example, they are called liquid organic hydrogen carriers that will absorb the CO2 as a liquid. Then when you go changing the conditions, the pressure, or the temperature, you can dissolve the hydrogen.
That's clever.
That's one. But there are other ways, which is the one that is used or is thought to be used now at large scale, that is converting hydrogen into ammonia. A little bit of chemistry now again. So ammonia is the fertilizer. So ammonia is N, nitrogen, H3. So one atom of nitrogen, 3 atoms of hydrogen. Not 4 like methane, but more than water that has 2. And easier to break.
Right, that was going to be my question. Where's the point in breaking it from one thing to make it into another thing to then break it again? It was like,
well,
why
there
are we
are
doing
two.
this?
Is an excellent question. There are 2 reasons.
Okay.
One is that it's easier to break. The other one, it has no carbon. So it has nitrogen. So NH3
And nitrogen, we're not concerned about
doesn't
that.
emit CO2
Okay.
because it has no carbon. So you can produce hydrogen however you want, convert that into ammonia by an industrial process that is very well known and mature. Now will be green ammonia, which you can see in the media. If the hydrogen is green, it will be green ammonia. If the hydrogen is blue, it will be blue ammonia. This ammonia is a liquid, so you can transport it very easily. And then it can go through long distances, like from the UAE to Japan, from Australia to Japan, etc. Once you get the ammonia, now you have to decide. Can I use the ammonia directly as a fuel? This is something we are investigating. Dr. Dimitri Kiritsis is doing that.
Okay.
In the REACH Center. We have a lab there to work on this. So you can use ammonia directly, either as a fuel. There is still research going on to avoid emissions, etc. Or you can, again, break the ammonia molecule. Or you can have ammonia mixed with some other things. But for sure, transporting hydrogen as ammonia is safe in the sense that it's easy to handle. It's toxic and it's still flammable, etc., but it's easier.
All of this, like, it all sounds so exciting and it all sounds so brilliant and we're doing all of these cool things. But to me, it sounds still very intensive, especially from an energy sense, but also a cost sense. It's not, because that's my concern for it. It's like, yes, we're doing all of this, but we need all of this energy to transport it, and we need all of this energy to break it. So is it still a good payoff in the end?
Of course.
Okay.
It depends on how much do you care about decarbonizing.
Yeah.
Correct? So if you have to pay a tax for emitting CO2 or other greenhouse gases into the atmosphere, the whole thing starts to make sense.
Yeah.
And this is where it comes, okay? And then hydrogen, as I say, has been used always because it's needed for this application. So now what we are doing is using it in the context of decarbonizing, which now with the war, it's going to be a little bit delayed, I think. Yeah. But I hope it comes back again. And it's one of these solutions to decarbonize the society. Again, it's not that we will solve everything with hydrogen. We need to have this very clear. We cannot oversell hydrogen. But hydrogen can be used for sectors for which it's very difficult to avoid CO2 emissions, which we call hard to abate sectors. For example, aviation. So aviation is one of the huge markets in this country. We have two of the largest airlines in the world.
Yeah, but I'm also thinking rocket fuel again.
No, let me explain to you. Let me explain to you. No. So what happened is so the fuel that you use for aviation is very specific. It's kerosene. It's not the gasoline we use in the cars. It's another one. And it emits a lot of CO2 and, long distances, a lot of CO2. I guess you have seen that we pay actually part of the taxes, no? I went to the US in May and I have to pay twice the taxes. One is because when I bought the air ticket, it says already there I was paying the taxes. But then when I arrived, the organizers of the conference say, we have to pay the taxes of the CO2 we were emitting. And I said, someone is becoming rich here, no? But the environment is still suffering the same. So let's try to change that.
Yes.
So there is an urgent need to do this, and there are actions taken in this direction clearly. So kerosene is mainly the fuel we use in airplanes. Can we have a synthetic kerosene instead of having the kerosene that is produced from fossil fuels right now? Yes or not? Or can we have other fuel that is not that fuel? So there is a huge movement on using what is called synthetic fuels for aviation, in which you can use this green hydrogen and the CO2 that you capture. And then if you react CO2, let me finish. If you react CO2 with hydrogen, you can produce methanol. And from methanol, you can produce synthetic kerosene. As of today, I will use a sentence we use in my country, we are killing a fly with a canoe, correct? Because it's like, my God, how much energy do you need to produce hydrogen to capture the CO2 just to produce the same thing that you have right now? Correct? But if you do the balance on the CO2 emissions, this has non-CO2 emissions, net non-CO2 emissions. But we are working in other solutions, correct? For example, and there are different companies doing different things and different research centers doing different things. Can we have a hydrogen airplane? Can we have an electric airplane? So electric is difficult, correct? Because how much time do you need to charge this? This is why this is called hard to abate sector.
Yeah, you don't want to run out of energy.
No, because it's just to charge your car, you need 8 hours. Imagine an airplane, correct? But there are companies, for example, Airbus is designing a hydrogen airplane and a hydrogen airport, and this is happening in Germany, where the trains are also there. So Germany is really leading many of the hydrogen applications and lowering the cost, etc. Maritime, the boats.
Yeah, all logistics, all supply chain.
So all these logistics are hard to abate sectors, trucks, buses, trains. So in some of them it's much easier to put hydrogen. In some of them it's more difficult, like an airplane, because you really need to design the whole airplane, and then how do you put the fuel cells, etc. But this is going in this direction. So hydrogen can help in these hard to abate sectors. For example, for making steel also, there are green steel factories. Steel also produces a lot of CO2, very difficult to remove. So if you can replace part of the steel factory by hydrogen, or by capturing the CO2, we'll have green factories. This goes into, we need to do many different things to decarbonize this society, and hydrogen is one of them, but it's not the only one.
That's absolutely brilliant. Thank you so much for coming in today. That was such a great conversation.
Thank you. It was great. Thank you very much.